Thank you. I will not keep you too long before lunch, so I'll try to keep this fast and lightweight. So, is the microphone working? Yeah, okay. So today I'll tell you about games of voluntary and verifiable disclosure. So,
can I ask a question about the first slide?
Yes.
How can you be both Microsoft and LinkedIn?
Great question. Well, LinkedIn is owned by Microsoft since 2016, and so I'm employed by the first, but mostly work physically at the latter. I will try to tie this work to what I'm doing in my day-to-day, but the connection is tenuous. This is mostly from my graduate study days. Okay, so I was saying I'll tell you about a model of voluntary and verifiable disclosure. What this means is that the disclosure, the sender has a choice of whether to disclose information or not, but if they do decide to disclose, they have to disclose the truth. So here are some canonical examples of disclosure models of a firm deciding to disclose revenue information to the market, a job applicant disclosing information on their CV, such as their GPA, to a potential employer, or a politician disclosing information about how suitable they are for office to voters. So I'm not the...
That's less verifiable than the previous one.
Yes, but I have an example of verifiability coming up very shortly on that one. So I'm not the first one in this workshop to have cited Paul as the starting point for their analysis, and it's the same for me. So the seminal result in this literature is that we expect unraveling to happen. That no news, or that is the lack of disclosure, is interpreted as bad news by the receiver, and so that the equilibrium prediction is that all information will be revealed. Now, of course, we note that this is not the case in practice, and the literature has identified several frictions that stop this full unraveling result. So two of these frictions are that disclosure is costly, and so if you are a low type in some sense, it might not be worth it to pay the disclosure cost, and so low types can pool together. You might also not have the piece of verifiable information to disclose, and this also allows low types to pool with the uninformed types. Both of these stop the full unraveling result. However, they do not stop the full unraveling result if these frictions are small, meaning that the equilibrium prediction is still close to full unraveling. So what I'm going to show you today is that I'm going to present a different kind of force that stops this full unraveling result. So let me go back to these examples. One thing that these examples miss is the fact that really the information that these actors possess and can disclose is not one-dimensional. It's not just a single number. So firms can disclose their performance not just at the firm level, but they can product by product. They can split it by region or by divisions. Job applicants don't have a single number. They can decide which references to include, how detailed to include the transcript, for example. And politicians can, for example, disclose their tax returns. So it's hard. You can decide not to disclose it, but it's reasonable to think that this is a verifiable, that this disclosure is verifiable. Okay, and so my result is that multidimensional information, once we put this into the model, can stop unraveling. And I propose a new dichotomy of how to think about these disclosure problems. The traditional dichotomy is good news versus bad news. And I propose good news versus vague news. And the equilibrium prediction that I will show you shortly is that when senders have high type along all dimensions, then they will disclose all of their information. And then all other senders that possibly have a mix of good and bad attributes along different dimensions pool together. And so when I observe no disclosure or limited disclosure, this is only vaguely informative. It has only limited informativeness about the sender's type. And that this can be sustained in equilibrium despite no disclosure frictions and no commitment on the sender's side. Okay, so let me give you a simplified version of the model that we can analyze in full in 20 minutes. So the sender's type is two-dimensional and uniformly distributed on the unit square. And the sender can decides which dimensions to disclose. And if they do so, they have to do it truthfully. So the verification technology that I have in mind here is a simple one in which you either disclose one of your dimensions. You say, okay, my dimension theta1 is 0.7. I can also decide to disclose both pieces of information, but I'm not allowing for a complex signal such as, oh, my type is in this subset of the unit square. Okay, so this is really, you can either verify one dimension, both, or neither. Okay, now the receiver, which I will also call the market, forms rational expectations dimension by dimension after the sender discloses or chooses not to disclose. So with not that much creativity, I'm going to call these two beliefs X and Y. Note that, so these are the conditional expectation of that dimension, conditional on the entire message of the sender. So potentially what I decide to disclose about dimension 2 can be informative about dimension 1 if I did not disclose anything about dimension 1. Now note that because of verifiability, if I disclose, say, theta 1, then X is simply equal to theta 1. Okay? And now the final assumption is I'm going to impose this preference structure on the sender's part. Their utility from the game is the minimum of the two expectations. So for now, think of this as the sender is evaluated based on the worst of their two attributes. I will give a couple of foundations later on for why these are reasonable preferences in this environment. Okay, and we're going to look for perfect Bayesian equilibrium. This is nothing new here. So somewhat loosely, what I want here is that the sender's disclosure strategy be optimal given the market beliefs, and that market beliefs are correct given the sender's strategy when we can apply Bayes' rule. Okay, so let's find the equilibrium for this game. We can start with a conjecture of no disclosure. So what I'm drawing here is the entire unit square, and in light blue, these are all the types that decide not to disclose. Now, if this were the sender's strategy, how would the market form expectations? Well, okay, there's no disclosure, so this is completely uninformative about the sender's type, and both X and Y will be equal to 0.5. Right? On average, the type is 0.5. Now, given these market beliefs, is the sender's strategy actually optimal? Well, clearly not. All the types that are in the top right quadrant can do better by actually deviating to full disclosure. And since disclosure is verifiable, even though the market does not expect this disclosure, once it happens, their beliefs are correct, and this will put these, all of the top right senders on a higher utility level. And so they will deviate to disclosure. And in particular, they will disclose both dimensions. Now let's see if this one, so we did one step. Let's see if this is an equilibrium. So now, conditional on seeing non-disclosure, the market beliefs take into account, well, okay, it's some weighted average of this entire region, and the center of mass of this region has now shifted a little bit to the bottom left and is denoted with that blue dot. Now again, this is not an equilibrium because there is an L-shaped region to the top right of the center of mass that would be better off by deviating and disclosing both of their attributes. So up to now, this seems like the classic unraveling argument in one dimension. Let's pull it all the way to the end, or let's keep going. So now let's say that any type that has both attributes above 0.2 discloses both dimensions. Now, what is the market inference when they observe no disclosure? Now, clearly the market can infer that at least one of the two attributes is bad, but they don't know which. And by the way that I set up the problem initially, the inference that they can make along any one dimension is actually not that adverse. So if I observe no disclosure and say that I'm looking at dimension at the x-axis, now roughly half of the time, the x attribute is very bad because the type is in this left band. But approximately half of the time, non-disclosure is actually completely uninformative about the x-axis. And so the average is actually going to be okay. Now in this case, somewhere around 0.3. Now you see that actually this is also not an equilibrium, but for the opposite reason of before. Now there's an L-shaped band of types that would be better off that if they disclose are on some utility curve here, and could actually do better off by pooling with these lower types and being treated as if they were this point here. Okay, so this is also not an equilibrium. Now, in between these two regions, there is a fixed point depicted here, and this is, yes?
So you weren't completely explicit about what does the sender aim to maximize. I mean, it would seem that
In this case, the minimum of the expectations dimension by dimension.
the minimum of the two expectations, not the expectation of the minimum.
Yes, and this is crucial. The model will be very different if they were trying to maximize the expectation of the minimum.
So what would be like a justification for trying to maximize the minimum of the expectations rather than the expectation of what it would be paid by the market?
Let me jump ahead to that, and then we can come back to so I have a few foundations for this. So the first two relate to uncertainty on the sender's part as to which dimension matters for the receiver. So an extreme case is in which the sender is ambiguity averse, believes that there is only one of the two dimensions actually matters, but does not know which, and wants to maximize the worst case. So here so it is not the receiver who is looking at this as a multidimensional problem. The receiver either cares about X or cares about Y, and the sender does not know which. Now we can also do this with more classical risk aversion if utility over outcomes are sufficiently concave. So say that this is a CEO who is disclosing information about his or her firm's performance, and their wealth is tied to the stock price, okay? And they have decreasing returns over higher levels of wealth. Then you won't get those extreme min shape that you had before, but this kind of indifference curves will still result in the same partial unraveling being the equilibrium. Okay, now let me give a completely different foundation for these preferences. So say that I am and this is, since I work at LinkedIn, I had to set in a little bit of an example that relates to LinkedIn. I'm deciding what to put on my LinkedIn profile, and I know that my profile will be seen by multiple people, and that I have to convince multiple people to actually to hire me. And say that the two dimensions are my technical skills, for example, my grades in CS classes, and the other dimension is some representation of my soft skills, for example, all of my extracurriculars. And the only way to get hired is for both recruiters to actually decide to make me an offer, and say that these numbers represent the probability that I am above some bar. Now, in this case, I will only be hired if both people decide to make me an offer, and you get the same structure as before. Okay, so this was the equilibrium that we identified previously. And geometrically, what's going on here is that the center of mass of this non-disclosure region falls exactly on the boundary of the non-disclosure region. So I have this little picture of, yes, this can actually happen even in physics. As long as the center of mass is exactly on the boundary, there's an equilibrium. Now, a non-foundation, and this is what Noam was referring to earlier, is if the complementarity between the two dimensions is not from the sender's side, but is in the mind of the receiver. Now, this collapses to the one-dimensional problem in which the unique prediction is full unraveling. So, going back to these pictures over here, when the receiver sees non-disclosure, they know that the minimum of the two dimensions is below the threshold level. And if that is if the sender is trying to maximize the expectation over the minima, then this just collapses to the one-dimensional problem. Okay, so this is one equilibrium. Is it the only equilibrium? Unfortunately not. There is another equilibrium which is not interesting in this example. So if the sender always reveals both attributes, and market beliefs, in this case, are not pinned down by Bayes' rule because non-disclosure is off path, and a reasonable way to set those beliefs is to say, okay, that they are as adverse as possible. If you do not disclose a dimension, I'm going to think that along that dimension, you're the worst possible type. How do we get rid of this equilibrium? We can perturb the game a little bit by adding a small disclosure cost. So let's say that the sender incurs an epsilon cost for disclosing any one of their dimensions. Now, types that are exactly on the boundary of the type space, it's not worth it for them to pay this epsilon cost. They might as well decide not to disclose and be treated as the worst possible type. At least this guarantees a utility of 0 as opposed to a negative utility. But now that we have certain types that decide to not disclose, non-disclosure is on path. And the same kind of geometric argument means that Bayes' rule will put the market beliefs not at the boundary, but in the interior of the region. And so this breaks this equilibrium. As long as there's a small disclosure cost, the equilibrium does not survive. And a similar perturbation using a low chance of the sender actually not possessing or not being able to verify their attributes will have the same effect. Okay. What about selective disclosure? So up to now, all of the equilibrium have featured either full disclosure or non-disclosure on path. So a natural guess at what an equilibrium might look like is, well, if both of my attributes are good, I will disclose both of them. If I am only good along dimension x, I will disclose x, and similarly for y. Now let's see why this is not an equilibrium in this example. So say that I only disclose x, and this is my x type. Now the market will say, okay, I know that what your x type is, and I can infer, given the equilibrium strategy, that you're along this blue segment. So on average, your y attribute is going to be over here, so I'm going to treat you as this type here. Now, why is this not an equilibrium for these types? Well, all of the types that are above, on the blue segment, but above the blue dot, would actually be better off to deviating to full disclosure. So this argument can be extended to say that there is no equilibrium that features non-disclosure, that features disclosure along all dimensions except one. Because then on the remaining dimension, the traditional one-dimensional unraveling argument pushes all the way to full disclosure. So this is just an example, but in general, in 2 dimensions, there are no equilibria that feature selective disclosure. Okay, so now let me quickly tell you about how the model generalizes. So we can have more than 2 dimensions. And in this uniform model that I was showing, one result that comes out of studying the same equilibrium in higher dimensions is that the probability of disclosure goes to 0 as the number of dimensions increases. So when we start with dimension 1, the probability of disclosure is 1. The equilibrium is unraveled. In 2 dimensions, it's some intermediate probability of disclosure. And as the number of dimension increases, the probability of disclosure goes to 0. However, the analysis is not as crisp in multiple dimensions because there are many equilibria, including equilibria that cannot be refined away with the kind of perturbation argument that I showed you before. So they're including equilibria that feature disclosure along some dimensions and a mix of full and no disclosure along other dimensions. Other things that can be generalized are the preference structure. So you saw the min, you saw a couple of pictures that had this product structure. However, some degree of convexity in the preferences is needed. If you go all the way to affine preferences, then the kind of geometric force that puts the center of mass on the border of the non-disclosure region cannot hold. And so the only equilibrium will be fully unraveled. Similarly, the fact that the 2 dimensions were independent was not crucial. But if there's too much correlation along the dimensions and most of the mass is along the diagonal, then again, the only equilibrium will be unraveled. And we can also allow for asymmetric utility and prior beliefs. So a couple of implications or thoughts on how this might inform design of disclosure environments. So one thing that designers can do is to make disclosure mandatory or forbidden along certain dimensions. So other models of disclosure have suggested that making disclosure mandatory along some dimensions might crowd out disclosure along other dimensions where, say, the designer does not have the power to make disclosure mandatory. And so in my model, this gives the opposite prediction, whereas actually making disclosure either mandatory or forbidden along any one dimension increases in equilibrium disclosure along the remaining dimensions. And so if you cannot make disclosure mandatory, but you could, for example, forbid disclosure, this might lead to considerations around, okay, we can commit to a rule that considers fewer attributes than we would want to, but leads to higher degrees of disclosure. And then going back to that foundation that involved multiple receivers, private versus public disclosure matters. So if I am choosing what to put on my public LinkedIn profile, my equilibrium prediction is that I will disclose less than what I would disclose in private to any one of those recruiters that had different preferences, because to any one of those, if they only care about one dimension, and we both understand this, then the equilibrium is unraveled. Okay, so I went really fast. Just to summarize what I did, so I identify a new force that stops unraveling in disclosure models. So when we have multiple pieces of multiple dimensions of information and convex preferences over market beliefs, and that this force is a new force and it's independent of known forces around costly disclosure or uncertainty whether the sender actually possesses verifiable information. And I suggest a new way of thinking about this problem, not good versus bad news, but good versus vague news. Happy to take any questions.
Hi. One thing I did not completely understand is, are the values of the dimension independent, or are they correlated?
So the question is whether the type is independent dimension by dimensions. So in this example here, it's uniform, so in particular, they're independent. This can be extended as long as the dimensions are not too strongly correlated. In fact, if you instead think about negative correlation, this actually helps to maintain this result. Mm-hmm.
You showed the CV example earlier, and you had this x times y.
Yes.
So my question is, if it was the other way around, how would your model compare to it? My meaning is, if I will know x times y, this will be the information that I will disclose, and you as a recruiter will only care about x. As you're disclosing x times y, how is it like manifest itself in such a model?
So I don't have so the question is, if I am allowing other types of disclosure, for example, disclosing what indifference curve I'm on. Is that
function of the original value?
Yes, so I don't know the full answer to that question. In this model, I'm restricting to simple verification technologies in which that kind of message is not allowed. If I allow arbitrary messages, then there are equilibria that are robust and that feature that are fully unraveled because I have access to essentially disclosing along diagonals. So in your specific example of the x times y, I've not looked at that, whether that would. Thanks for the question.